Thanks for joining us today for the webinar, Making SAR Accessible with ENVI SARscape. Part of this will be focused on the new SARscape 5.6.2 release. My name is Bill Okubo. I'm part of the product management team here at L3 Harris Geospatial. Been with the company a long time, going back to when it was the original RSI private company. And today here to present is Megan Gallagher. Before I introduce Megan, there's a couple of housekeeping items. We are recording today's session and we have muted the line. So if you have any questions, please use the Q&A button down at the bottom and type your questions in there. And then after the webinar is done, as I said, we're recording it. We will make the recording and the slides from it available probably tomorrow. We'll send you an email with the link to that. So with that, why don't we switch to Megan and I'll introduce her. Megan Gallagher has been with L3 Harris Geospatial for about 4 years, mostly working with SAR data. She's a subject matter expert, and she's been the czar of expanding our metaverse of SAR user base. Before that, she got an undergraduate degree at Colorado School of Mines in geophysical engineering and a master's degree at Boise State University in geophysics with a specialization in remote sensing. In addition, Megan enjoys all types of active and passive systems at work and is very interested in all kinds of data fusion techniques and how they can be applied. And on top of that, Megan is a cat lover. So with that, Megan, I'll turn it over to you. Thank you.
Thank you very much, Bill. The cat may or may not make his own appearance during this. We'll find out. Before we jump into everything, I'm going to go over a bit of an agenda. First off, an intro to L3 Harris Geospatial, who we are. If you don't know, this is a good way to find out, and just sort of why I'm here. Next up, we're going to talk about the main point, which is how to make SAR more accessible. This is going to be sort of an overview of my opinion on things I've seen, especially here in North America where I'm based, and how we can hopefully start helping more people use SAR. And to do that, SAR Map has also done a lot of stuff that we're going to be talking about as well with the new update of 5.6.2 for SARscape. We're going to take a really quick look at SAR and optical, then vegetation analysis, activity monitoring, and then displacement. Lastly, we're going to be looking over some workflows, workflow changes, updates, and overall ease of access. So let's get started. I'd like to give you guys a little bit of background on L3 Harris and L3 Harris Geospatial. L3 Harris is a global aerospace and defense technology innovator. We deliver end-to-end solutions that meet mission-critical needs. We here at L3 Harris Geospatial focus on geospatial solutions, including commercial analytics, custom projects, data, and machine learning technologies. We have over 30 years of experience in scientifically proven solutions using cutting-edge technology, including ENVI, our well-known software program for imagery analysis. There are many other analyses that we provide as well, from real-time weather updates, multiple styles of classification, and the ability to easily process SAR data, which is why we're here today. ENVI is an imagery analysis software that is used internationally for scientifically proven analytics and processes. It supports hyperspectral, multispectral, LiDAR, and SAR, and pretty much anything else you can think of. It works fluidly with ArcGIS as completely automated workflows for many different techniques. And today, like I said, we're going to be focusing on ENVI SARscape. ENVI SARscape is used to easily process and analyze SAR or synthetic aperture radar data. This can be used from things such as time series analysis to DEM creation to time series deformation monitoring. ENVI SARscape has built-in workflows to simplify processing, so even if you've never worked with SAR data before, you'll have the ability to easily get those output products. SARscape has full integration with the ENVI suite of tools as well, so any outputs or processing that you do in SARscape can then be used in ENVI for further classification analysis or even deep learning techniques. I'm not going to be talking too much about this today, but I did want to bring it up, which is the ENVI SARscape Analytics. This is the grab and go version of ENVI SARscape. It's a lighter package with multiple analytics provided that anyone at any skill level can use. You pretty much just need to have SAR data and to know what you want to be looking for. You can choose your analytic, put in your data, and that's all you need to do. And with that, let's get started with our main topic. So SAR in optical, what we see and what we don't. I started off as an optical remote sensing scientist. I was mainly multispectral and hyperspectral data fusion between those techniques. And then I learned the SAR, but I was really lucky to have that geophysical background to begin with, because I'd worked with active sensors before, even if they were subterranean for the most part. And this seems to be one of the biggest movements changes. In the remote sensing, especially in North America, we tend to be mostly optical, multispectral, hyperspectral, and a little bit LiDAR based when we're doing our techniques and just technology in general. Because it's what we see. Red, green, and blue, these different colors that we can all see to certain extents, or most can see to certain extents, are combined in different ways. And maybe we're going beyond just those red, green, and blue, but it's still a physical representation of an image that we're used to. And so we understand it. Maybe we're switching and we're using spectral indices, but it still isn't a format that we see around us. But with that, then, when we start moving into some more of these active sensors, especially with SAR, that can cause a little bit of a gap in between what we are used to seeing and understand and what SAR is seeing. A great example, and what we'll be talking about in a bit, is vegetation. If a plant is green, it's probably healthy. There are a lot of times it's not, but more often than not, if a green is good. For SAR, how can, just given an image, can you tell if a plant is healthy or not? It depends. You can see the reflectance response, and maybe you can see if it's very highly reflective, it's a lot of vegetation there that's reflecting back. But can you make those kind of interpretations right when you start off? It takes a little bit of effort. So whether you're here as a SAR expert and you already know how everything responds, or you're here because you're new to SAR, hopefully there'll be some stuff in here that can just help out. Now, because SAR sees what we don't see, because it's in the microwave and radar range, we get some pretty good information from it, however. Optical has an issue called clouds. We get to see what the sun is reflecting. So the sun hits the earth and then it hits a cloud. And so we see the cloud from our sensors, or the sunlight, excuse me, not the sun. And so we see that cloud from our sensors, and it covers up the information that we need underneath it. For things like constant monitoring, this can be a major issue because we cannot always say we will see what we need to see exactly when we need to see it. SAR, on the other hand, is an active sensor. This is the same as LiDAR as well. These are sensors where the energy comes from the sensor, interacts with the ground surface of some kind, and then is reflected back. Because of this, it can see through clouds, and it can see day and night. And so that allows us to have this constant monitoring of through ash, through clouds, just whenever you need it, wherever you need it, it is there for you. So though our eyes might not be the most used to it, it gives us exceptionally valuable information, like with vegetation. So vegetation and with optical remote sensing is probably one of the top 2 things it's used for. There are thousands of spectral indices out there, such as the Normalized Difference Vegetation Index and EVI, or SAVI, the Soil Adjusted Vegetation Index, that are used to see what is the quality, what is the greenness, what is the health of our plants on the ground. We use it to do land cover mapping, illegal deforestation monitoring, to track invasive species. We use remote sensing, especially in the optical range, a lot over vegetation. The issue is where there's vegetation, there's usually water, and a lot of the time this comes from rain, which means clouds. So back to that issue we have where clouds cause us no end of trouble in our optical world. SAR can also be used to look at vegetation. You can track growth. You can monitor how things are changing between fields. In fact, this beautiful image I have up here, which is one of my favorites, is of rice fields using SAR data. And all the different colors are the different stages of reflectance and growth, and we can quantify that in these images. But sometimes understanding how we can do that is sort of the first step we need to take. For example, we have here an image of Sentinel-2 and TerraSAR X over some fields in France. For the Sentinel-2, you can pretty easily say, oh, those fields are growing crops right now. They're green, they're growing. It's pretty obvious. There's a little white part, maybe that's plastic on top of the fields, or underneath where the crops are to stop weeds. We can make some inferences based on just the imagery itself. But if it's your first time using SAR, you can take a look at that right image and it might be a little bit more confusing. Now, if you've used SAR before, white means brighter reflectance, meaning there's probably vegetation there. The darker areas are flatter and maybe there hasn't been, like it's a flat area that hasn't been sown, it doesn't have seeds yet. But you sort of have to do that comparison between the two. Once you know it, you got it, but it takes a little bit of time to get there. And so that's one of the first things that SAR map worked on. And that's the Enhanced Dual Polarization SAR Vegetation Index. So this is a vegetation index for SAR data to match with your optical data. And what this does is it uses a dual pol system to create an estimate of land cover based upon the amount of vegetation, pretty much synonymous to NDVI. The index is scaled with a color scale that ranges from brown to dark green. Brown corresponds to low reflective areas, such as arid soils or water, while dark green corresponds to areas with higher reflectivity that can correspond to more dense vegetation cover or urban centers. So any kind of SAR imagery that has a dual pol sensor, so VV and VH, or HH and HV, can be used in this process, as well as if you have coherence information, so that phase information between scenes, you can use that to get even better indexing and information from it. So this is our first step to sort of make it easy to do a comparison between your SAR and your optical data. Another one of those top 3 things we see all the time in remote sensing is to use it for activity monitoring. I mean, that's what it started off as. We're trying to see things that we're not there for in an easily quantifiable way. And like I've brought up multiple times, clouds. They can cause us a lot of issues when we're trying to monitor something actively. Whereas with SAR, we can see through them, as well as some features that we're very interested in can give very unique responses with synthetic aperture radar. Ships, for example. Most ships on water, if it's relatively flat, shine like beacons when we're looking at them with SAR. And because of that, we're very easily able to identify most of them. For this one, we can see this example is a look at the Ever Given. On the left-hand side, we can see it wedged inside the canal. And on the right-hand side images is an automatic ship detection and counting of the amount of ships that had to wait for the canal to be cleared and the Ever Given to make its way out for them to all be able to pass through. But with this, once again, we have a minor gap. When I look at something with optical data, as long as the resolution's good, I can usually guess what I'm looking at. For me, I might not be able to say exactly what kind of ship it is, but I'd be able to say, oh, maybe that's, this size of ship or this kind of ship, or looking at planes, for example, as well. And with SAR, the reflectance response is, once again, not something our eyes have been trained for most of our entire lives to work with. So if you wanted to guess what kind of ship it was, that could be a little bit more work, which unsurprisingly leads to the next thing that has been worked on. So ship detection. First off, there is compensation for the Doppler effect to improve matching between AIS signal and detected radar data. AIS is the automatic identification system information. This is, you can think of as GPS tracking for ships. They're supposed to say where they are, and some of them even say what they're doing or who they are, but a lot of times this is moved or obfuscated, hidden away so they can do things they might not supposed to be doing out there. And so this is better matching and targeting between your imagery itself and that GPS, as well as there is now classification of identified ships using a neural network trained on Sentinel-1 VV data. So this only works with Sentinel-1 10-meter data, but what it is it automatically will classify ships as cargo, tanker, fishing, and passenger ships. And so, we might not, like I said, I might not be able to call these out immediately, but there's already a system now in place to help train the system and me on what kind of ships I'm looking at. Related to that, in AIS, if you're looking at the SAR imagery, we've also made it a lot easier to know what you're looking at. Previously, there would be a little marker for your AIS data that'd be on top of your ship to tell you where it is. But now there's also just automatic information, so that generate annotations of ships. And in this case, you can see in the bottom where it has been generated, it says the name of the Stena Dramatica in this case. So the name retrieval between the matching allows you to just have that easily overlaid on top. Now, something that comes up really often that if you haven't worked with ship detection in SAR, you might not know, is land is a major problem for us, and we like to just completely mask it out. This is because it will just add noise and confusion and things we don't want to deal with inside of our processing. But if I wanted to automate shift detection, water moves. Where the land is moves because the tide moves. And so you have to have a full understanding of how the tide works. And I don't personally want to go in and draw a map of every single change in tide. So that has been done. This tool uses both the imagery that you have from SAR as well as tide heights that you can download through SARscape as well, and pretty much auto extracts and creates these coastline vectors. And so you can see this coastline extraction of different color lines refer to the coastline according to the different tide levels. And so now if you want to automate shift detection, you can, because we can remove the land's effects and make sure we don't get false positives and get rid of a lot of the noise that we might previously have had. So this is a very exciting thing, and I'm very happy to be testing this out and tracking all those different abilities that this can give us as well. Next up then is the thing that synthetic aperture radar is probably the most well known for, and this is displacement. With optical data, when we're talking about displacement, we usually are talking about photogrammetric collects and then comparing them to each other. And this is fine, but it only works on specific scales. SAR, on the other hand, is really well known for being used for displacement. So it can be used to monitor and track that displacement by using phase, and this is usually collected alongside the amplitude. So you get a literally complex waveform for most SAR sensors. The phase change shows minor shifts in the ground surface related to when a specific part of the wave hits the ground at what time. The change in time can then be tracked in between images and used to find ground surface change. This image here is an interferogram of the BAM earthquake. And as someone who is a geophysicist, I can look at this and be like, ah, yes, I understand what those colors mean. However, if you not, this doesn't make any sense whatsoever. Why are there lobes? What do the colors mean? What is the stretching? And of course, that's one of the first things that we worked on, is to make it a little bit more accessible for people to understand. For example, this is a look of persistent scatterers, which is a long-term displacement tool that is used to track displacement at millimeter scale accuracies with a whole bunch of images. So those areas with the red pixels are showing areas where there is major change. And we can track those changes in displacement and, maybe mitigate things, monitor things, see how things are with this kind of tools. Persistent scatterers works with these persistent reflecting responses. It works very well in urban areas, but not as well in rural areas or areas that have vegetation. So for this mine, for example, in these mountainsides, it worked very well. But in areas where you're trying to say, maybe you're monitoring a landslide that has vegetation over it, it might not catch everything. So the tool for that is called SBAS, or small baseline subsets. This tool is much better at finding areas of lower coherence, lower similarity, where things might change, such as vegetation swaying in the wind, or making it so we can't always hit the ground exactly as we'd like. But previously, you could not do this automatically. There were 2 steps in this process that you had to go in and do yourself. The first one was checking every single interferogram to make sure that they were okay to use, because there can be noise. And the second one was the inclusion of GCPs. Previously, you'd have to supply your own GCPs, so GPS points, for example, or you'd go through the system and generate them yourselves based off of points within your processing that were the most stable. Now, however, it has been completely automized. The GCP choosing is now done in the background with the system, where you can go and have those points chosen by the system itself, which ones are the most stable, and used to make sure that your velocity modeling and all that stuff in the background is correct. This imagery here is showing our ENVI task, each one of those a little task every box, and this is the ENVI modeler. This allows you to string things together, and so this is a full SBAS process that I can, move it to Python if I'd like through the IDL Python bridge, or I can port it over to ArcGIS if I want to work over there. I can move it up into an enterprise environment and have it run in the cloud, because SBAS uses a lot of images, so that's usually a good idea. But this is now fully automatic, and you can just have it running over your areas of interest. And the picture on the right is in Argentina. It's a look at oil fields, and the black points are wells. And so this is looking at the displacement of injection and extraction, the injection of water and the extraction of gas, where we're able to see that ground surface movement. Now, one of the things that comes up with this is if you're working with this kind of system, you want to make sure you know what you're working with. And so there is also now this displacement time series classification tool. So this performs the classification of displacement time series by means of external temporal phenomenological data, such as rain and temperatures, etc., or analytical displacement models, linear, quadratic, and sinusoidal. So when we're tracking movement, not all movement's the same. We can have things that are moving linearly. We could have things that are changing seasonally. There's a lot of different kinds of movement out there. And this actually helps you quantify that kind of movement so you can get better velocity models or a better understanding of how things are changing, as well as you can compare it to weather effects such as rain, temperature, changes that are occurring on the ground surface that are really important to understand why things might be happening or why you're getting the responses you are. So this is a great tool for understanding your stuff, for helping you wrap your head around it, as well as a good QA/QC tool. Speaking of QA/QC tools, we also now have the Coherence Matrix Viewer. This enables the literal analysis of the coherence behaviors in time series, where rows and columns represent the acquisition dates. Coherence can be thought of as the similarity between two scenes. This is used for interferometry and is pretty much how much has changed or how much has stayed the same in between them. So you can use this to analyze behaviors in time series, such as target detection or growing crops for crop monitoring, or to help you with SBAS parameters. Is your imagery good? Is it well connected? Is there some scenes that are just noise and you should get rid of? And there's no limit on the number of images, which is a horrifying thing to say. So you can change the quantity of both the columns and rows. This is an amazing QA/QC tool, but also just to use on your own to see where those kind of changes are occurring. Taking a step back when we're looking at things that are different between optical and SAR and things that might trip you up if this is your first time using it, SAR is a non-nadir sensor. This means that pretty much it doesn't look straight down like we do with most optical data. And because of that, we look at things from line of sight. And this changes how we view things. It has some geographic effects on how we're viewing things like mountainsides and valleys and the angles that we get things at. And it's really important to understand and know which way our satellite is going and how it's looking at our ground surface. So there is now a Generate Annotations raster tool. This will automatically pull up both the heading of the system that you're using and the line of sight, as well as generate information such as the sensor, the satellite, the polarization, the date, the incidence angle, and the data unit that this imagery is in. And so you can use that to understand what you're looking at, and it'll pop up there, or you could have it generate itself when you're done with processing as well. This is really useful, and I was quite happy when this popped up the first time. Another thing for ease of access and use is the intensity single image workflow. This is a full process from just importing and having your data ready to multi-looking, filtering, and geocoding. Previously, so we have a multiple image intensity time series workflow, and that does the same thing for multiple images and also gives you an output of statistical information, mean, max, min, etc. But we didn't have one for single images. Instead, you'd have to go through the tool, like the processes, the tasks, one at a time. So this is just to make it much easier to use, have it all run. You can have it as a single tool and it'll do all the work for you. Related to that, we also have the Coherence CCD timeline and power tool, or task, excuse me. Coherence CCD is using that coherence, that similarity that I talked about, and doing change detection, so coherence change detection. And it looks between that similarity between scenes with both the amplitude and the phase, and uses that to show us what kind of changes are occurring on the Earth's surface. So this is really good for looking at things that you might not be able to see with optical data or even with SAR intensity data. For example, rivets, wheel marks, and sand. You can see that with CCD. So you're able to see where things are, where they were, and those minor changes with the phase. And so this tool not only outputs that CCD output, but also gives you the power or the reflectance, the intensity image response as well. Just makes it easier to use and have a handle on everything altogether. Another thing we've added is the support of UAV SAR. So this is a NASA JPL airborne sensor that is L-band and is freely available. The link is here, and we will have these PDFs out afterwards. So you can go take a look at it as well. I would highly suggest it. It's very good. It is over a limited area because it's mainly where NASA or their partners have tasked it. And so you can sort of compare and contrast and have that all available. And I see a question in chat. Jody, would you mind answering that one real quick for them? Because that is a good point. I am watching chat. I will answer the questions at the end, but I am paying attention. Yeah, related to that, with new missions and new sensors and more, we also are now supporting the SID format. The SID format, or the Sensor Independent Derived Data format, is designed to store synthetic aperture radar data. So this is derived image products and associated metadata that is grouped around common tasks for downstream users. It is meant to be used in conjunction with the Sensor Independent Complex Data, or SICID, format as an interchange, sensor and software agnostic standards for SAR imagery. Pretty much SID and SICID are standardized SAR data processing techniques, or not processing techniques, but data that is spread and used pretty commonly. So we now support this. The validation is not complete for all of it. We also have support for StriX by Synspective, which is an X-band sensor that has both sliding spotlight and strip map, as well as HiC1 by SpaceT. This is a C-band sensor that has spotlight mode, strip map mode, narrow ScanSAR mode, and extra ScanSAR mode. And I'm watching the question in chat, and we'll see. So the import processes have been validated using a small data set. For reasons, radiometric calibration and absolute geolocation have issues, so ground control points might be necessary to improve the quality of geocoding. Another thing that's been added is the European Center for Medium Range Weather Forecasts, the ERA 5 download. This allows you to query and download meteorological data provided by the European Center of Medium Weather Forecasts. It still uses the ERA 5 dataset, which contains global reanalysis data from January 1979 to present, computed each hour with a granularity of about 30 kilometers. This is very useful to understand what kind of weather is happening when you're collecting your image or when it's actually being collected, so you can see what kind of changes are occurring. Related to that, we also have the GACOS. I'm not quite sure how to say that every time, but the GACOS tool. This tool allows the importing of the generic atmospheric correction online services for INSAR interferometric stacking processing. And this is really great. This allows us to model the atmospheric effects and then use that to remove those atmospheric effects from our INSAR processing and our interferometric stacking processing. So removing a lot of the noise that occurs there. And that's sort of the goal of remote sensing, is how much noise can be removed. And this is a great tool to use to help for that. Some other follow-up stuff that's been changed is for persistent scatterers. You can once again use the GACOS tool to help remove that atmospheric effects, as well as faster interferometry, first inversion and second inversion. For SFAS, there's that automatic refinement and reflattening. GCPs are not required anymore. The GACOS can be used for that as well. The topography-related atmospheric pattern removal based on the unwrapped interferograms has been added. You can mask areas that have layover and shadowing, so that's geographic effects, as well as areas that have low coherence, and faster refinement and interferometry. Point cloud DEM fusion is used between DMs that are generated in SARscape that creates a point cloud in between them to create a fusion product. And so you can use that now as well. Multi-looking is available for ground range data, so GRD data, as well as we have that single image filtering in gamma and Gaussian filtering. We also have interferometric multi-looking. So this is multi-looking over interferometric output files. And now you can do interferometry with ALOS PALSAR too. So we have some new tasks as well. So like on that picture of the ENVI modeler that I showed, all those little boxes were tasks. Everything within SARscape is taskified. And so these are what those new tasks are called. And so I'm not going to read all these out, but it is lots of new tools and lots of new stuff to play with. And with that, I will take any questions.
Thanks, Megan. Great presentation. There's a lot of exciting new features in this new 5.6.2 release of SARscape. New sensor support too. It's great. So there's a number of questions. Before we jump into that, I just wanted to restate again that we've been recording this presentation. The presentation and the slides will be made available to you. We'll follow up with an email to send you a link to download those. So, all right, let's take a look here. There's a question about what is the accuracy of DEM that's created from SAR data?
Okay, that is entirely dependent on your data itself, like in your background DM for creation. For example, I would never use Sentinel-1 ever for any kind of DM creation. Sentinel-1 is a freely available sensor that is designed for displacement. It's just the way it's collected, and we can go more into it than, we can go more into it later if you'd like, or you can email me afterwards. But it should never be used for a DM. So the accuracy really, really does depend upon the sensors that you're using. So I'm not going to actually be able to give you a definitive answer for that one. I'm sorry.
Okay. And then there's another general question about, can SAR actually find minerals?
Ooh. So we can see responses, and those responses are affected by the dielectric constant of what they're interacting with on the ground surface. So things like water can cause issues, and of course, materials have these dielectric constants. But to have them to such a degree that it would respond in that way, I'm going to say no. You can see different changes. And if you have something that's very different from the ground around it, it may or may not reflect differently, but probably not enough to separate out different kinds of minerals from each other.
Okay. But then, maybe that gets to some of the general remote sensing capabilities in ENVI around multi and hyperspectral imagery. All right. A question about the accuracy. What is how accurate is the vegetation index with SAR?
Yeah, so accuracy. Yeah, accuracy of what? I'm sorry, this is a very open question because it's doing it based upon the reflectance response of how much reflectance there is. And so similar to how NDVI scales up an image, this is a SAR index, a spectral index. So accuracy, I would say it's accurate on the stuff that we've tested it on, but that is always going to be scene dependent. Your NDVI is going to change depending upon your scenes, as long as you have a reflectance, and we have a scaling that we're used to, similar with this. So I'm not giving the best answers for this, but that's try to think of it as similarly as an optical spectral index as you possibly can.
Okay. And then another one about snow cover. Does that affect the displacement using Sentinel-1 data? Meaning, do we have to discard those images when processing as PSI or SBAS?
That is a great question. The answer is yes. So snow can cause a snow end of grief. We can see through most weather, but snow on the ground and sometimes even snow in the sky can cause us a lot of noise. When we're doing displacement in areas that have snow, SARscape will actually pretty much automatically ignore those if the coherence is too low. And then you can either choose to connect the dots or interpolate in between the different seasons. So for example, if you were doing an entire 2 years and you went to fall, you could more or less ignore winter to go to spring. And that's part of the processing itself, because snow and the moisture and the response and the coverage on the ground will mess up our active responses. So that does exist, but it is accounted for.
Great. Okay. And there's a question about, can distributed scatters technique be done in SARscape? I'm not familiar with that.
Yeah, so currently we have small baseline subsets and persistent scatterers techniques. So those are the ones that are currently available at SARscape.
Okay.
Currently.
There's a question about GPUs. Can that be utilized for persistent scatters or SBAS?
So this has actually been a very big topic recently. The GPU is utilized in some of parts of the processing of PSI and SBAS. We use OpenCL to help with CPU processing as well. So if you have a laptop, that most of them have that kind of system automatically. If you have a desktop, it's actually part of the downloads for SARscape. So the GPU is used during some of the processing. But that is something that's being talked about and worked on. So I might be able to get you some more information later on that as well. That's a bit more definitive.
Okay. There's a lot of questions, so I'm not sure we're going to get to all of these. There's one quick one, maybe I can pick, Megan, and then we'll wrap up unless you want to answer one or more others. There's a question about, SAR can be used to measure displacement. Can it be used to measure volumes?
All right, so yes, vegetation-wise, there are a couple different ways you could do that. First off, you can monitor and actually extract biomass, which is words you're not allowed to say with optical sensing most of the time with SAR. You need to have in situ information if you do that. It needs to be comparable. You need to know what you're looking at. You need to have someone on the ground to do so. But also there is now a new there's a new task, which is a tomography task as well. This is included in the interferometric stacking, so with persistent scatters and SPAS, and that allows you to do tomographic studies. This needs a specific kind of collect to do so, but you can do it. And yeah, so that's a couple different ways, but you need to be pretty on top of things if you're doing either of those. You need some ground system information to make sure to make sure it's all good. Similar with soil moisture mapping.
Okay. Are there any last comments you want to make, Megan?
I mean, these are all great questions. If I didn't get to your questions here, we will have them all so we can get to them afterwards and hopefully respond to you guys.
Yeah, okay. Well, thank you again, everyone, for joining us today. Thanks for the great presentation again, Megan, and we'll see you all next time.